Hi, ladies and gentlemen, it's Mr. Green, and I'm continuing with my lessons on statistics here. We're looking at probabilities, and we're going to look at independent and dependent situations. But before we get into that too deeply, let's think about the situation where we're going to use permutations and combinations together. Okay. First of all, we're looking at this problem here. It says 12 cars are parked next to each other in the parking lot. What is the probability that they will line up from oldest to the most recent from left to right? Well, how many solutions are there going to be in this situation? There's only going to be one. Okay? There's going to be one total situation that matches this probability, one event where that occurs. How many are there total? Well, this is where we're going to use the permutations. Okay? Since there were 12 cars in here and they were going to line up uh, from oldest to left to right, I'd say you take 12 at a time. And you would be able to work that out. Why are they saying 8? Hmm. Obviously missed something in the question. They would line up 12 at a time. But they're obviously saying that there would be 8 parking spaces. Okay? And so we would have 8 possibilities here, and you would take them 8 at a time. Now the second one down here, you've actually got 2. You say from oldest to the most recent in either direction. You've got 2 possible solutions here, but it's still going to be that permutations of 8 over 8, 8 out of 8. Down here on these other ones down here, you've got 12 taxis in a parking lot. 3 are chosen for inspection. What's the probability that 3 cleanest ones are going to get picked? Well, this is going to be a combination because it's not order doesn't matter here. But there's only one combination where they're all 3 are the cleanest ones. So it's going to be a combination, and it's going to be 12 and 3. This one, what's the probability the 3 cleanest or the 3 dirtiest are picked? There's 2 possible solutions for that one, and that'd be a 12C3. Now, I'm not working those out, but you can see that they are worked out here for you. Okay? So you can use permutations and combinations in many different ways here. So one of the things that comes up frequently is using probability without doing a replacement. These are independent events. If you do a replacement of it, they're not independent. They're dependent upon each other. The other way around. If you do a replacement in there, they're independent. If you do not do a replacement, they are dependent upon each other. Okay? Let me show you what I'm talking about here. There are 7 red and 3 blue marbles in the bag. Okay? If they replace them after the first one, there is a 7 out of 10 possibility of getting a red and a 3 out of 10 possibility of getting a blue. But since they put that marbles back in, whatever they drew, for red it's still 7 out of 10, and blue it's still 3 out of 10. And for red it's still 7 out of 10 and 3 out of 10. If we didn't put it back in, 7 out of 10 to begin with and 3 out of 10, but we don't put the marble back in. Now there's only 9 marbles in there, right? And only 6 of them are red here, so it'd be a 6 out of 9 and a 3 out of 9. Down here, it'd be a 7 out of 9 and a 2 out of 9. How do I get these different numbers? Well, if I don't put the blue one back in, I can't have 3 blue ones to choose from, so there's only going to be 2 blue ones to choose from. And I have 1 less marble in the bag, so there's only 9 in there now. And so it changes the numbers. That's what we're talking about with independent and dependent. Okay? If I don't put it back in, it's dependent upon the previous draw. If I do put it back in, they're independent events from each other, and I can treat them that way. Okay, so wanted to make certain I got that clarified for you guys. I'm going to be going on, and I will look for you next time.